All right, welcome to the first part of the memory unit. Let's go ahead and get started. I'd like to start by talking about a famous case study in the memory literature. This is a man named Solomon Shereshevsky. Um, During his lifetime in the memory literature, he was simply known as S. And S was a pretty normal person, or so he thought, until at some point in his 20s, he had a job as a newspaper reporter. And the editor of that newspaper called everyone in that morning on a particular day, and he was giving out assignments for the day. You're going to cover this, you're going to cover this, you're going to cover this, make sure you do this. And everyone was furiously taking notes, making sure they got everything written down that the boss was saying, except for Solomon. Solomon was just sitting there. He didn't have a pencil, he didn't have a notepad in his hand. And the boss took this as an insult. The boss, the newspaper editor, thought that Solomon simply wasn't paying attention. So he tried to call him out on this, and he said, Solomon, repeat back to me everything that I've said. And he proceeded to do just that. He said everything that the newspaper said verbatim. And the newspaper editor was simply floored by this. He had no idea that Solomon would actually do what he asked him to do. This was the first time in Solomon Shereshevsky's life that he found out his ability was unique. Up until that point, he thought everyone had the same memory ability that he did. Uh, he's able to remember incredible feats of memory. So, once he was discovered, he was sort of made famous in the memory literature. He was brought into a bunch of different laboratories, and people did lots of different experiments with him. It was found that he could memorize numbers that were 70 digits long just reading through them once. He could remember the full lengths of poems that he read through just once. Even though he had no idea what the different mathematical equations he was given meant, he could still remember them and write them out just by glancing at them once. So he has this amazing memory ability, and one thing that he was often asked about is, are there any downsides? Are there any side effects, negative side effects to having this amazing memory ability? And he said there was. He said he did not have the ability to forget. So he could not forget some of the bad memories in his life. He usually gave the example of his divorce. The divorce was a very painful memory, and he cannot remember the intricate, or he cannot forget, rather, the intricate details of that divorce. Imagine a very painful memory from your own past, and yet you have exquisite memory of every single little detail of that painful event. So Solomon Shereshevsky is perhaps the one end of the continuum of memory ability. At the other end of the continuum, we have people like Clive Wearing. Now, I'll have a short YouTube video if you'd like to watch it about Clive Wearing. I strongly encourage that you do. He has a very, very poor memory. His memory is about 5 seconds long, which means he lives his life in this series of disconnected 5 second time spans. It's completely disorienting. He gets pretty frustrated pretty quickly. He is living in a home. He might have passed away by now, actually, but the one thing that he seems to remember in his life is his wife, which is kind of endearing. He remembers that he has kids, but he has to constantly be reminded what they're doing and what they're up to. And he was a famous pianist before he lost his memory, and he still remembers how to play the piano very, very well. But in the video, you'll see that he actually keeps detailed journals of what happens throughout the day. He's trying to help himself remember. He knows that something's wrong. and he thinks that keeping these detailed journals will help him remember. And it's kind of sad to look through these journal entries because about every minute or so, he'll write down, this is my first moment of consciousness in my life. This is the first moment that I can remember being alive. And it's just a series of these different types of revelations, one after the other. So think about that. Every 5 seconds, his memory is basically flushed, it's wiped clean. So every 5 seconds, he's sort of coming to consciousness for the first time in his life. Very disorienting, very unfortunate situation to be in. All right, so we have this memory continuum down here at the bottom of the slide. This continuum encompasses all human ability when it comes to memory. We have Solomon Shereshevsky on one end of the extreme, and we have Clive Waring on the other end of the extreme. The vast majority of people are going to fall somewhere in this average middle part of the continuum. That's where you and I are probably going to fall. So what is memory? Well, that's what we're going to talk about next. So memory is the act of storing information, and then just as importantly as storing that information is retrieving that information. So getting it into our minds, and then when it becomes necessary, getting it back out of our minds. So it's kind of two key processes there, storing it and then using it. This is important for so many things in our lives. Daily tasks like using the bathroom, tying your shoes, brushing your teeth, those rely on memory. You remember how to do those things. You don't have to relearn how to do those things every single day. How to use a cell phone, how to drive a car, how to use a computer. Those all rely so heavily on memory. Personal information, your phone number, your address, how to get home after school, after your job, how to get to your job, how to get to school. Those types of personal information, that's entirely dependent on memory. Just imagine if you couldn't remember your own name. Personality, who we are as people, our behavior, our habits, our personality, our emotions, believe it or not, those also depend on memory pretty heavily. So it's this incredibly important thing. Without any sort of memory, we would be in this Clive Waring. I struggle to think of a better word, but it's almost like a hell. The inability to remember anything for more than 5 seconds sounds absolutely awful. So, how do psychologists, how do psychologists model memory? How do they talk about memory? How do they think about memory and study it? How do they bring it into a laboratory? Because if you think about memory, it's this kind of abstract, ethereal phenomenon. How do we describe it and use it in scientific terms so that it can be pretty much put under a microscope and studied? So, one way that psychologists do this is by creating models of memory. So, let's talk a little bit about what a model is in a scientific sense. If you took a dictionary and looked at the definition of a scientific model, you might get something like a simplified metaphor of a complex real world phenomenon. So, what does that mean? A simplified metaphor of a complex real world phenomenon. Something like memory is our real world complex phenomenon. It is very complex, and we want to know more about it. In order to know more about it, we are going to basically make some assumptions about how it works and simplify those assumptions to create a model. Now, a model is something that we can bring into the laboratory. We know that our model is not exactly what memory is, but it's a close approximation. It's something that we can test using scientific tools. We can't directly test memory. It's too big, it's too broad, it's too abstract. So to help break it down and help us understand it better, we create these models. So a model helps us understand the foundational assumptions, the foundational principles of what memory is. Now, when we're making these models, we have to walk this line. We can't make a model that's too complex, and we can't make a model that's too simple. If we make a model that is too complex, it is too similar to our real-world complex phenomenon. And remember, that real-world complex phenomenon is something that we don't understand. If we make a model that is just as complex as that phenomenon, we're not going to understand the model either. So we have to be able to understand the models that we create. But if we make them too simple, then they lose power, they lose usefulness. If we make a model that is so simple, like a very simple box and arrow diagram that has one box and one arrow, which we'll see something similar to that very soon, then that's not very helpful. If we can't make predictions about it, if we can't actually draw conclusions from it, then it is a useless model, just as if it was too complex. So there are several different models of memory, and we're going to talk about some of the more common ones here. One of the most common ones is the three-stage model. So this model of memory breaks memory up into three different stages. They consist of sensory memory, short-term memory, and long-term memory. So let's talk about those in some detail here. All right, so here's the three-stage model of memory. This model is a boxes and arrow diagram. These are very, very common in cognitive psychology. So these boxes represent a process, a cognitive process. Inside this box, information comes in. That information is processed, meaning something is done to it. It's transformed in some way. And then it is sent on to the next process, the next box. And these arrows represent the flow of that information. Information comes from here, and then you can see in this blue box, sensory memory, it has two options. It can follow this arrow, meaning it is unattended and forgotten, or it can follow this arrow. We attend to that information, we pay attention to it, and then we send it on to short-term memory. Okay, so that's the basics of the boxes and arrow diagram. The three-stage memory model in particular here on this slide, we are going to first focus on sensory memory, then we'll talk about short-term and long-term memory. So just focusing on sensory memory. Sensory input. This represents all of the information that we are bombarded with all throughout the day on our senses. Our eyes, our ears, our skin, our nose, our taste buds. All of that sensory information is hitting us all throughout the day. And we're going to talk specifically about visual sensory information. So all of that visual sensory information, basically your entire visual field, which is a lot of information, is captured in a very brief snapshot in your sensory memory processes. And your sensory memory processes briefly scan that snapshot of your visual field and discard the vast majority of it, and it follows this arrow. It's unattended to, and that information is lost forever. But in that visual field, there may be one or two or three very important pieces of visual information that might seem important. They might need to be attended to a little bit more. If that's the case, those little bits of pieces of information are pulled from that snapshot and passed on to short-term memory through our attentional processes. So just to reiterate here, we've got this huge wide net cast. We've got our entire visual field. A brief snapshot of our visual field is captured in sensory memory. Sensory memory briefly scans it. We're talking like 100, 200, 300 milliseconds here. And it's briefly scanned. Most of it is forgotten, but a couple key pieces of maybe possibly important information is passed on for further processing. That's sensory memory in a nutshell. So let's talk a little bit more about it. When we talk about these three different stages of memory, we're going to talk about them in terms of two dimensions, capacity and duration. Capacity is how much, duration is how long. So how much information is stored in this stage of memory, and then duration, how long is it stored in that stage of memory. So capacity, do we talk about that on the next slide? Yes, I think we talked about it on the next slide. Okay, we'll save that for then. Duration, we'll also save that for them. So if something is important in that visual field, in that brief snapshot, we pay attention to it, which means it's passed on to short-term memory. That's what is meant by short-term memory, STM. Now, we only know that sensory memory exists because of a man named George Sperling. And he created this experimental task called the Sperling partial report task. And I just want to briefly present that task to you now. So what Sperling did is he showed participants very briefly, we're talking 50 milliseconds here, a grid of 9 letters, a 3x3 grid of 9 letters. And I'll show that to you in just a second for those 50 milliseconds. It's a very, very brief flash. I can't stress that enough, how short that grid is going to be on your screen there. And what he did is he had two conditions. He initially asked the participants to report every single letter that they saw, all 9 letters. And people did pretty poorly on that. So I'm going to show you what that's like right now. All right, 3, 2, 1, here we go. All right, did you see that? Pretty brief, right? I've seen this hundreds of times by now, and I usually only get about 1 letter, that letter K that maybe some of you saw in the top left. That's a 50 millisecond flash right there. That's exactly how long George Sperling flashed the grid for his participants as well. So in the whole report condition, you flash this grid, and look, there actually was a K there. I got 1 right. I didn't remember anything else. Got the K though. So you see this grid for 50 milliseconds, and then you're asked to report every single letter that you saw, all 9. And people did really poorly on this. I got 1. Maybe you got 1. Maybe you got 2. Maybe you didn't get any. It's a really hard task. So he switched it up. He then started what's called the partial report condition. So in the partial report, you're still flashed the same grid for 50 milliseconds, but this time, immediately after that 50 milliseconds is up, you're going to hear a tone played. That tone is going to be high frequency, medium frequency, or low frequency. If you hear the high tone, you only report the top row, KZR. If you hear the medium tone, you only report the middle row, QBT. If you hear the low tone, you only report the bottom row, SGN. When they were in this condition, the participants were at 100% accuracy. And remember, this is important here. They didn't know which row they were going to have to report at the beginning of the experiment. They didn't know which row they'd have to memorize. So it's not like they heard the tone and then they were just looking at a particular row. They heard the low tone, they were looking towards the bottom of the screen. They were not doing that. They saw the screen, the grid, and then they heard the tone. So what they're doing is they hear the tone and then they quickly report the 3 letters in whatever row it was that the tone corresponds to. So what's going on here? Well, George Sperling, again, this was the first task to kind of highlight this idea of sensory memory, that it even existed in the first place. And Sperling highlights this idea of what he calls degradation. Degradation, sometimes it's called decay now in current literature. But in these two different conditions here, the whole report condition and the partial report condition, you have differing amounts of degradation. So you're flashed that 3x3 grid, it's briefly stored, and then after that 50 milliseconds is up, you're asked to recall either the entire 3x3 grid or just 1 row. So if you're in the whole report condition where you have to report all 9 letters, you start reporting, okay, I saw a K, your attention is going to that top left corner where that K was, and then you move across to Z, your attention moves to that spot where Z was, then you go to R, your attention moves to that R was, and then you've already forgotten everything else in there, if you're lucky enough to get to that third letter even. That's what I mean by degradation. As you're thinking about, as your mind is recalling that information and pulling it out of sensory memory, everything else is being forgotten. So when you're asked to do the whole report, you forget as you are recalling. Now let's contrast this with the partial report condition. You only have to recall one row, top row, middle row, or bottom row, which only is 3 letters. So people are much, much, much better at this task because there's less degradation. You can get through 3 letters. You can get through the process of recalling 3 letters much faster, and then you get to the third letter and you don't have to recall anything else. So it doesn't matter if everything else is degraded or decayed. So the basic idea here is that the partial report condition allows for reduced degradation of the intended target of recall. So thank you, George Sperling. And with some further testing based on George Sperling's initial data here, we now call this iconic sensory memory. This means it's referring specifically to visual sensory memory, and it lasts for 300 milliseconds. So that huge amount of information, your entire visual field, is stored in your sensory memory systems for less than a third of a second. So 300 milliseconds, that's 300 thousandths of a second. But this is a vast amount of information. So let's go back to that duration and capacity idea. Duration is listed right here, 300 milliseconds. That information is stored in your sensory memory very, very briefly. So duration is 300 milliseconds, very short. But capacity is enormous. Your entire visual field, every piece of visual information that is bombarding your retinas, that's a lot of information. That is what is stored very briefly. So capacity is huge, but duration is so minuscule. And there we go. Duration, 300 milliseconds, capacity, entire visual field. And remember, these two dimensions are going to be really important to know about for each memory stage. All right, so there's sensory memory. Let's move to the next box in the diagram, in the model. And just to recap here, visual information comes in, briefly stored here, sensory memory scans it, forgets the vast majority of it, pulls out, 3 letters or whatever is important, and throws it onto short-term memory. Short-term memory is where a lot of magic happens. So information comes into short-term memory, and a couple different things can happen here. Short-term memory, the idea of it has changed quite a bit throughout the years. We now think of short-term memory as kind of the same thing as attention. Now, that's not an entirely true statement, but for our purposes, that's totally fine. Think of short-term memory as our attentional processes. Short-term memory is what you are currently paying attention to, what you are consciously currently paying attention to. So if you're looking at this slide and you're focused on where my mouse is right now, you're looking at this green box that says short-term memory. That is currently activated and attended to in your short-term memory processes. So let's say you are in the process of getting someone's phone number. Maybe there's a cute girl or a cute guy. You don't have your phone on you. You don't have anything to write anything down, and they just give you their phone number. So you have to remember it. So that information comes into short-term memory, and you desperately want to remember it. So what do? You repeat it to yourself. You rehearse it over and over and over again until you get to your phone or a notepad and pencil so you can write it down. So that's what this arrow is represented by here, this looping arrow here. We continue to make it activated in short-term memory so that we don't forget it. Because if we forget it, it follows this arrow here. Unrehearsed information is lost. So if that person told us their number and we simply didn't repeat it to ourselves at all, it would be lost. We'd be forgotten pretty quickly. You may have experienced this if you've ever gone to a party and been introduced to someone new and then immediately forgot their name. I know I personally have done that many, many times. Someone introduces themselves, they say their name is Brian, and lo and behold, 10 seconds later, I've completely forgotten what their name is. That's because I was not rehearsing that to myself. I wasn't saying to myself, okay, this is Brian, this is Brian, this is Brian, this is Brian. That would actually be a very smart thing to do if you want to remember that person's name. Maybe you don't. All right, so we've covered 2 of the 3 arrows here. We've got, you can rehearse the information, repeat it to yourself. If not, it's going to be forgotten. If you repeat it to yourself long enough, if you pay attention to it long enough, it will eventually be passed on to long-term memory. All right, let's talk about short-term memory. We're going to talk about duration, we're going to talk about capacity, and short-term memory has been studied, I would say, more than sensory memory has. That's what SM stands for, sensory memory versus STM. STM is short-term memory. So sensory memory is unconscious. We don't have control over our sensory memory processes, at least not in any real tangible way. Short-term memory is very different. We have a lot of conscious control over our short-term memory processes. We have a lot of power over what we pay attention to. We have a lot of power over what we repeat to ourselves, rehearse to ourselves. So that kind of makes short-term memory a little unique. Think of short-term memory as sort of the bottleneck of this system. This 3-stage model of sensory memory, short-term memory, long-term memory. Sensory memory casts this huge, huge net, remember our entire visual field, and just a couple key pieces of information are removed from that net and passed on to short-term memory. So we go from a huge net to just a couple pieces of information. And then if that information in short-term memory is successful in getting passed on to long-term memory, then once again, we have this huge store, this huge reservoir of information in long-term memory. So sensory memory, big, short-term memory, small, long-term memory, big, once again. Kind of creates that bottleneck imagery. So let's go on to duration. How long is short-term memory? Now, this is a very contentious question, and the answer to this question has changed quite a bit since the 1950s. But the 1950s was really one of the first stabs at answering this question. So this is a research team, Peterson and Peterson. It's a husband and wife team back in the late 50s. And they tried to devise an experimental laboratory task that would stop the participants in the experiments from rehearsing the information that they were expected to remember. Remember, if you rehearse it, it's going to be continually activated. It's eventually going to be pushed on to long-term memory. But if you can't rehearse it, then we're going to find out how long it stays in there without rehearsal, how long it would stay in there and just sort of fade away over time. That's what we're interested in. How long would something stay in short-term memory without doing anything to it? That's kind of the heart of the issue. So what they did is they devised this experiment. It's pretty clever. And they thought of these random letter strings. And they gave the participants a couple different random letter strings to remember. So JLU, RWP. And they told them, all right, remember these. We're going to ask you what they were in just a few seconds. But in the meantime, they didn't want the participants just repeating to themselves JLU, RWP, JLU, RWP. So what they did is they had this distracting task. And the task was to count backwards from a specific 3-digit number by threes. So you might be given the number 121, and you're told count backwards by 3. So that would be 118, 115, 112, 109. It's not a particularly difficult task, but it takes most of your attention. It takes most of your attention to focus on that distracting task so that you are not rehearsing to yourself the things that you were supposed to remember.